So how can virtual reality be used to make better informed decisions, essentially the presentation of this title. And I'm going to give a bit of background to the industry, the size of it, where it's going, the types of projects that we've been doing, and where the potential is for immersive technologies. So VR, who uses it? Essentially, the primary users today are people working in the games industry. Entertainment's picking up a lot on it. Marketing is using it. And the military have obviously had the budget to be able to spend money on some of the more expensive kit out there. NASA has also used VR simulations and is currently using VR simulation to prepare astronauts for interplanetary space operations and spacewalks. So there's a number of headsets out there. They range around between 500 and 700 pounds, and they need to be hooked up to a relatively high performance PC. Obviously, applications are driving simulators, horror games, first-person shooters. Obviously, the first-person shooter relates nicely to military applications for training. And actually, the omnidirectional treadmill we have, its primary purpose is to allow military operatives to actually practice different scenarios. So before that, there'd be a load of chipboard structures in a forest, and they'd run around and try different scenarios. With VR, and this omnidirectional treadmill gives them contextual and physical capability to try out different scenarios and think about different tactics. So at the other end of the scale, there's Google Cardboard, which is a fold-up piece of cardboard with some lenses, and there's also the Gear VR, which you take your smartphone and place it into, and it gives you a reasonably high-performance VR system, but it's accessible and can be distributed. The content can be distributed to people anywhere. So that's really great in terms of showcasing what VR can do and getting it out to the masses. And this lightweight, cheaper solution. I've only been to Alton Towers recently. If it wasn't scary enough to be in a roller coaster, in reality, you can now get all kinds of birds and things flying out at you and dip and dive around a virtual world with all the physics and the G-forces of a roller coaster, but being somewhere completely different. So it allows you to do more with what you physically have. And then, so virtual reality, just to make sure everybody's aware and understands, virtual reality requires you to recreate that everything you see, the whole environment needs to be three-dimensionally created, digitized, and put into a format you can then experience. And the VR headset is a viewer in that space. Augmented reality, and what the Hololens does, is overlay information into your existing environment. And applications that have been showcased by Microsoft involve potentially having a television of any size in any room, one that follows you around, to be able to have your recipe book in your kitchen without getting sticky fingers all on every page, and to be able to have information superimposed on your real environment. Now, the trouble with the headsets today is that you're required to wear a headset, and some people find that a bit odd. Don't really want to walk around the house with a big bulky thing on their head. But there's some really exciting technology being developed. A company called Magic Leap, who are, I think, the only company that I'm aware of who's managed to secure over £1 billion of worth of investment and have actually produced a prototype or exposed that prototype to the masses. But that's going to be a retinal projection system. So you could have something potentially as lightweight as the Google Glass or a pair of glasses, and images will be overlaid, will be projected into your retina, negating the need for headset systems. That is a few years away, though. So in terms of the market size, in 2016, the overall market was over £1 billion, and that was predominantly made up of £700 million worth of hardware kits, and then application software sales was £300 million. However, VR is actually the little brother of augmented reality. There are a number of reports out there talking about the potential size of VR. This one in particular from TechCrunch, I picked up yesterday, predicts that that AR will be $83 billion, within a market ranging between 94 and 122 billion by 2021. Now that's 4 years away. That's quite interesting because a lot of people haven't really adopted this yet, and I think for the wide-scale adoption of these technologies, we're going to have the skills in the businesses and identify those killer applications and how those systems can be used. So one of the barriers, which I'll talk about in a few minutes, is actually, have we got enough skills coming out of education? Have we got enough of the people with the right backgrounds to be able to take this new technology and apply it to their own industries of interest? This is another report from Goldman Sachs. It is a year old, but it still actually hangs true. The optimistic business case by 2025 was 120 billion in this report. Now, the previous report says in 2020 that will be the same quantity. So you can see a number of sources are looking at all these applications and really seeing huge potential. And this is a pie chart just showing the potential market applications. One thing that's really close to my heart is because VR creates an emotional response. There's something about having something on your face and isolating you from the environment that creates a physical and emotional response. And I think the education sector is going to hopefully we need content for that, but it's going to transform the way we educate our children. This example, if anybody has a VR headset or wants to, this is a good excuse to get your kids interested in different areas. This is a simulation for the Apollo 11 mission from launch to going to the moon and coming back. There are VR demos of what it might be to be on Mars and navigate around that. And something I found last night, which we talked about 3 years ago, is a program which is building CubeSat. So they're kind of, I think, a foot squared satellites that are being launched with different functions. And this one here is a VR camera view of the Earth. So using the Gear VR or Google Cardboard, so kids with their own smartphones will be able to log into this satellite, which is launching next month, and they'll be able to look down on the Earth and see as it passes in low orbit around the Earth. And I think being aware of the effects we're having on our environments is going to have a profoundly deep effect on children and how they think about their planets, think about what they do and how they behave, how they think about waste and recycling and the way they move around, the effect that transport and moving millions of people around the globe all the time. So I'm really excited about that. I'm going to be buying access to that as soon as it's available, because I think that'd be cool, a good way to fall asleep at night looking at the Earth and the sky. So what research are we doing in Immersive Technology? So obviously we're focusing on transport applications, but we're having to learn from other industries. This image here is what the Omni deck was originally used for, which is for training infantrymen. We're actually linking up different types of simulators, so tank simulators, aircraft simulators, all into one common space. And I'll come back to that in a minute, because I think that offers huge potential of bringing people together in virtual reality for different applications. The construction industry have been using 3D virtual caves, where you can have multiple people inside there, but one person with control. Driving and flight simulators, and the automotive industry is using mobile phones and augmented reality to provide instruction manuals to people who are in their cars. There's never enough time when they hand over a car to explain all the features, so what better than actually to look at the thing you're trying to press, understand what it is, get some videos and information about how it works, and to be better informed. And this is particularly important with ADAS systems, so advanced driver assistance systems, which are the precursor to full autonomy. What do they do? How do they react? What do you need to do in those circumstances? It's really important that people are educated about what they do and when they do it, because the majority of the time they're going to be in a sticky situation when the system intervenes, and they probably won't be aware, because they've never seen it before, as to what it's going to do and how they should react. So that's a really interesting use of trying to recreate a dangerous situation in a completely safe environment and educating people about those circumstances and what they need to do. So through our research, visualization is part of the modelling and visualization team, and my modelling colleagues look at transport simulations. So our role with them in particular is looking how to make transport simulations come to life, make them more interactive, more dynamic, being able to think of how we can bring stakeholders into something which is a very complex scenario with lots of iterations, and how they can manipulate those simulations, how we can move simulations to be live, agent-based simulations, allows you to have the hand of God. Imagine you're looking at a simulation, right, I'm going to turn that turnstile off and see how pedestrian flow changes. I'm going to create an accident here. Let's change the weather. Let's get all these things dynamic so people can start to play with what's the art of the possible. Going through the barriers at the moment to wide-scale adoption. Hardware costs are coming down, so that's coming out of the equation, but still a barrier. Software skills, as I mentioned, people with the right skill sets to create the content. Building environments for transport is particularly challenging because transport is quite big, and creating content is tight, it takes a lot of time, it's expensive. So we're investigating how we can accelerate the creation of those 3D worlds. And what it really comes down to is how accurate do you want it, how fast do you want it, what do you want to do with it, what are your future ambitions for using that model, what additional applications can it have in your business. So counting the number of steps, for example, in a station could be done manually. But you could also do that with a LiDAR system, which could extract the number of stairs from that information. And actually doing that for the one application could have ramifications for simulation. It could have ramifications for understanding what you have now and what's happened in the future. You could use it for information, if you can digitize that, so you can tell people where to go for wayfinding. It has numerous applications. So there are some really cool technologies coming to the front now, which their price points are dropping massively. So we're trying to understand what the market's doing, and we want to be that place where people come to understand, well, how do we create these scenarios? And I think the conclusion we've come to, anything is possible, but how much budget have you got? What would you want to do? And how do you want to reuse that content and equipment in the future? So there's a slightly bigger picture of the lab. This was finished last June, and we've been filling it with exemplars of the latest kit, learning about that kit and finding interesting examples of how that technology can be used. So we see this facility, which is obviously part funded by the government, as a cost saving and an information source for people to come to. So if you're interested in getting into VR, there's a steep curve of learning and understanding, what should you buy, how should you use it, what skills do you need. If we have the kit at this location, which you can come to, we can give you that expert advice, because we've been using it for a number of years and we understand what does work and what doesn't. We're also an independent party. We're not tied to any manufacturers or software vendors, so we can give impartial advice about what would be best for you and your organisation. The digital Catapult, we worked with them to add additional content and equipment to both of our facility, and they're now doing the same thing in their respective industry. And in fact, the other Catapults, high-value manufacturing, been looking at three-dimensional CAD models and engagement already for a number of years, but the Future Cities Catapult and the satellite applications are all looking at buying in relevant tech. So we're sharing ideas, we're sharing knowledge, experience, and we have the potential to share hardware and facilities so that we can optimize and customize the things that we can offer as services, and insight into those technologies, how can be applied in those different industries. And on the side of doing all that, the Catapults and a few other leading organisations have been working with KTN. We've just, at the end of last year, formed a representative group body for all companies across industry working in immersive technologies. So that's augmented reality, virtual reality, 360 videos, mixed reality, etc. And the purpose of this is to network those organisations together, so we can learn from each other, we can see opportunities, we can collaborate, and also we can canvass Innovate UK, for example, and say, look, this is really cool, this could be applied in this way, to create new calls for innovative research in that space. So check it out. I think I've over 700 members now, not even more. So. And as I mentioned, one of the objectives and one of the services we want to offer to the market is to be that showcase. This is what we can do, this is what's out there. We're looking at allowing people to learn via workshops. So if you have a project of interest where you want to see what immersive tech might do in a long-term project, how it can be an impact, we can organise a workshop, we can bring our kit, we can bring in SMEs, academia and industry experts to participate in workshops to help you understand what it means to your industry, to your business, to your future projects. And then we can help to coordinate groups of companies to deliver that service, or if highly innovative and nobody's doing it, which week on week, you can finding out new things people are doing, we can provide that expertise and guidance. So either project management, support activity, or a doing activity. So project-wise, and I think this links onto a presentation from the Royal College of Art, thinking about human interaction with autonomous vehicles. So virtual reality gives us the ability to de-risk experiments. So if you think about doing experiments with autonomous cars in the real world, you've got to drive an autonomous vehicle at somebody, it's got to do something, and it's got to be safe. I think you can all imagine the insurance risk assessments, cordoning off parts of urban environment, getting subjects put in that place, and then of course after all that the weather messes around with your experiments and changes the variables. So what we've been doing is we've digitised Milton Keynes from here down to the station, which is one of the routes the pods that we've been building will take. And we are now superimposing on human interface designs, so HMIs, which include visual as well as behavioural from the pod, the way it moves, and auditory triggers, so that we can actually place pedestrians into that virtual environment using the OmniDeck. We can fit biometric sensors to them, including eye tracking, heart rate, respiration. So we can see we can hear what they're saying. That thing scared me. I didn't like that. I didn't understand it. It moved in a weird way. And also see how scared they were or how happy they were. And we can collate that information together to get a much more rich picture of what that design concept meant. So I'm going to play a quick video of one of those trials in motion. Okay, so from this experiment that we've done this prototype, we're actually now working with a UK automotive OEM investigating this area. And the more people we speak to in the industry, the more of a challenge this is in understanding what the vehicles should do, how they should behave, what they should look like. So we're open and available for input to anybody who has an interest in that space. And the thing that's really, really powerful about the use of VR and the design process is actually in something as innovative as autonomous vehicles, there are potentially thousands of different ways you could think about communicating with pedestrians. What VR allows you to do, although there's an upfront cost of creating the environment in which you want to test, it allows you to rapidly iterate all these different ideas. So with my time at Jaguar Land Rover, it was a real issue as a human factors person to actually get hold of vehicles, believe it or not. It was even harder to get an engineer to interpret your ideas and turn it into something physical that could then be tested in an experiment. That whole process takes forever. And so we ended up doing experiments. You're holding bits of card in a lab saying, what do you think of this? What do you subjectively believe? VR gives you the ability to put people in context, to make them feel immersed and part of that environment. And it will bring up a whole load of other granular details that you just wouldn't get in traditional means of experimenting with users and interfaces. So I think it's got a huge potential in the design process to do more work up front, involve more stakeholders in that process, and as a result get better concepts identified earlier on and used throughout the process as opposed to constantly reiterating. So I think it's going to affect the cost and timescale of doing all this. So on to another project. So we spoke with the RNIB probably just over a year ago, and we're talking about VR being fantastic for gaming, giving you superhuman powers. And the conversation then led on to, well, actually, could we take away your abilities? Could we actually allow you to experience what it might be to have a physical impairment, so you can't walk particularly fast? Can we actually take away your vision impairment? And at that point, we saw a bit of a light bulb moment as actually this technology could affect what you see because we can manipulate the environment you're seeing and how you see it. Now that has led to a project where we've created an augmented reality simulation called eyewear. It's available on iOS and Android. The original intention was to educate people about visual impairments too, so they can understand what it might be to have to travel and experience their environment through the eyes of somebody else, to raise awareness, to create a level of empathy. But that's really snowballed into a whole lot of other applications. So we're looking at training members of staff so they become more empathetic, and using the RNIB's experience and skills to make sure they've got the right understanding of what it means to help somebody with a visual impairment, or what it's like to be somebody with a visual impairment. We're looking at how we can use that application to design new interfaces, web interfaces, printed media. And the potential is huge. If you want to think about usability, inclusiveness, and accessibility, particularly visual impairments, that's the only one of its kind that's out there. So here's an example of our colleague Ryan walking around Milton Keynes train station. So we can show the 4 of the 6 different visual impairments we've simulated. On the app, you can change the severity by up to 3 different levels, so early, intermediate and late stage progression. And you can actually use it as a means of auditing your environment. So if you're a station manager, you can see what it's like. How do people see that? How good is your signage? You could then allow your staff to role play with each other once they've had the education and understanding of what visual impairments and living with visual impairments is like, so they can improve their customer engagement, so they can help people at the right point. And a lot of the assumption with disabilities is that people need to have a wheelchair because it's just easier. That's the last thing people who have a disability want. They want to be able to navigate themselves. So this is just a really, really useful tool for creating empathy and understanding. Okay, so on the back of that, we've now created a virtual reality version of it, because actually walking around what exists is great as an auditing activity, or maybe at the end of a project where you want to assess how well you've actually implemented those ideas. There's a big hole in the middle. You know, when you're working in 3D, when you're working with different concepts, how can you understand and iterate and change those concepts live? So this is where we're going to attempt a live demo. So a couple of weeks ago, we went over to an organisation called the Lighthouse for the Blind, who provide advice and guidance for people with visual impairments. So it tends to be how to live with a visual impairment, cane skills, how to get a job, how to manage those various conditions. And Michael over here is going to demonstrate what we've been able to achieve. So hopefully, if we can put the camera onto the screen over there, and people online can also see. So this is a recreation of the Lighthouse for the Blind in downtown San Francisco. This is a 3D model that's been created from a blueprint. So from a two-dimensional drawing, we've created the environment, and we applied materials and textures to that environment. And we created a user interface which allows you to cycle through visual impairments rapidly. As you can see, Michael's now going to go through visual acuity, different eye conditions. So as well as the overlays from the app, we can now actually do visual acuity, which is the depth of field you can see. So you can look at how in the distance some people perceive signs, how colour actually affects the communication of those tools. And actually, the Lighthouse for the Blind is a really bad example of how good this can be, because it's been designed specifically by experts with visual impairments. But it shows what can be achieved in terms of an inclusive space. So you notice all the chairs are red. The actual walkways are polished concrete. The places to stand and wait and communicate are carpeted. The lighting is exceptionally good. But all those things we can edit, so everything's in real time, so we can actually move the sun in the sky, we can change the lighting levels, we can apply different colours and textures to the walls, and we can actually see how sunlight reflects off those walls and how that scatters in that environment. We're going to shortly move to a dynamic level of eye condition simulator where different angles of light will affect the way the eyeball receives that light, so you can actually create additional glare, so a reactive visual impairment simulator. So that was, thanks Michael. We haven't done as much as I wanted, but I know we're running out of time. I want to show you something else. So if you're interested in this, come have a chat with us later on. So this is an example, if you couldn't see over there, so these are some of the images of the different rooms in there. And one of the really interesting ones is the colour palette materials section in the empathy lab. So all the materials in that building can be placed together, and you can cycle through colour blindness, and you can see how those materials take on a completely different meaning with people with vision impairments. You can look at how far away you can see objects, and you can manipulate and add models into that space. So we've got a number of tools in that now, but now we're looking to add additional content with clients as they want to explore what can be done. So we've had a really positive response, and Airbnb went back to offices immediately, started using the eyewear app to design their web portal. Yahoo were going to use it to train their staff about visual impairments and accessibility. The potential tools created in VR to bring people together, discuss problems is great, but VR is inherently isolating because you have one person with a headset. So I'm going to go on to collaborative VR now. So there's a few facts I found on the web last night. 488 million miles, business trip miles, are conducted in the USA every year, 1.3 million a day. This obviously requires planning, organising a trip, where you're going to stay. It costs a lot of money, and some people might find it difficult to travel. So what are the percentage of those people didn't need to travel because they could engage with each other, talking about three-dimensional objects and spatial awareness in a more engaging way by staying in their offices or working from home? So what we're asking ourselves is, what could we do if we can enable anybody to join in a VR session from not just a high expensive VR system platform, but from your own laptop, from a mobile phone with a VR headset? What if we could do that seamlessly? So if you're on a construction site, you need to be part of a meeting back 100 miles away, you could join in and you could look at what people are talking about. And unlike today, where we might have a two-dimensional plan, you start pointing out and drawing on it, you can actually walk into that space and point at things and talk at them and edit them live, and then save that file, a bit like a game. We play a game, you save it, and you've got what you had before at the starting point, and you've got the completion point. You can actually record all the discussions that happened in that session and everything that was edited. I think that's going to be hugely powerful in the way we work, and an additional tool. Not for everybody, but I think it could have a significant impact on CO2, on travel, on costs and productivity. So this is our second demonstrator. So Michael over there is, okay, it looks like a dungeon, but we're using assets we can get hold of. And we've created a museum, but this could be any space, any transport hub, airport, train station, open public space. And you can see that, so Michael, through a simple Wi-Fi connection, is able to move around this space. At the moment, we've just got gesture and voice comms, so we can talk, you can point. He's connected to Carl in the lab, and is also connected to our partners on Infinity in Sweden. So this is all done for a very low bandwidth connection. We're all using VR systems in this case, but we have connected a tablet and a mobile phone and a laptop. It all communicates through a common protocol and can allow people to anywhere just to engage this activity. So you can start to look around spatially about information displayed in that space. You can look at lighting. You could potentially grab hold of these objects and move them around. I think from a gallery curator's point of view, this could be really exciting. So you not have to get people to lift up statues that are 100 kilos and move them around. You can just go, that looks good there. And then the interesting thing about these assets is that they have longevity after the initial design activity. So, because we really are short of time, and the clock's gone to 0, so I need to wrap up. Thanks, Michael. Again, if you want to go on that later on, just give us a shout, and we'll hopefully schedule something in for you. So, immersive technology is more affordable than ever. There's still a skill shortage out there, which we need to help resolve. It can give incredible insight to complex issues and create greater engagement with stakeholders much earlier than we could ever do before. We can rapidly iterate designs and test options and test things with end users earlier than we ever could do before. Assets can be created early on, but they have longevity through the product design life cycle, but also in adoption. So thinking about designing a train station, the security forces could look at it, people who are going to work in that space could be trained in it, and you could look at all kinds of things like adding in additional pop-up kiosks and looking at how pedestrian flow might be affected. So it's an expensive initial activity, and that will come down with time as technology solves these problems going from 2D to VR, 3D content. But it is feasible today, and there's the potential to save businesses millions of miles of travel, reduce CO2, and enable teams to work more efficiently. Thank you very much.